Lesson 8.10, Solving a System of Equations with Substitution. So we discussed previously, but I'd like to review what a system of equations is. A system of equations is a set of two equations that share a common point that is known as the solution. The system can be used to solve for real-world situations. And the solution looks like this. When we have two graphs, two lines that intersect, the solution is the point where the two graphs intersect. The solution for the system is an ordered pair xy that represents that intersection of the two lines. And we had three methods for solving systems of equations: graphing, which works well when we don't need an exact answer, or if the numbers involved are relatively small. We had the addition method, also known as elimination, which works well with any set of equations, and is especially useful when equations have non-integer coefficients. And then we had substitution, which works well when one variable has no coefficient, or when one line is horizontal or vertical. In the last lesson, we used addition or elimination, and in this lesson, we're going to use substitution. Substitution is a property of numbers. It's very similar to substitution in the real world. So if we were to ask someone for change for a dollar, they take your dollar and give you 4 quarters. This is substitution of one thing for another, and both things have the same value. That's what allows you to substitute them. So in math, we can use this property to solve systems of equations. We remove one expression and we replace it with another that has the same value. And this allows us to eliminate one of the variables in a different way than we eliminated one before. Okay, so we want a variable equal to an expression. That's the first type of substitution. So we'll have 2 examples of this. Okay, so now what we have, 2x plus 2y is equal to 14 and y is equal to 5x minus 11. We're going to take what y equals. Y is equal to 5x minus 11. And we have another y. This y and this y are equivalent. So I can take this y out and put what y is equal to in its place. So I have 2x let's try that again. 2x. What's going on with my pen? 2x plus 2y. Well, I'm going to take y out and put what y is equal to in. 5x minus 11 is equal to 14. So we replaced this that way. Now I distribute the 2. So I have 2x plus 10x minus 22 is equal to 14. Combine my like terms. 12x minus 22 is equal to 14. Add 22 to both sides, and I get 12x is equal to 36. Divide by 12, and x is equal to 3. Now I know what x is equal. I can plug that x back in to this equation, and I can find out what y is equal to. So I have 5 times 3 minus 11, because x was 3. So that's 15 minus 11, and that's 4. So y equals 4. So my solution is the point 3, 4. Here I have x is equal to 2y minus 21. So this value and this value will be equal as well, and I can substitute this in. So instead of having 7x, I'll have 7 times 2y minus 21 plus 2y is equal to negative 19. Distribute my 7. 14y minus 147 plus 2y is equal to negative 19. 14y and 2y are like terms, so 16y minus 147 is equal to negative 19. Add 147 to both sides, and I get 16y is equal to 128. Divide both sides by 16, and y is equal to 8. Now I know that x is equal to 2y minus 21, so if I plug in an 8, I get 16 minus 21, and that is negative 5. So my solution is the point negative 5, 8. Keep in mind always that x comes first in the ordered pair, even if you find the value of x second. Now, sometimes it's all not set up to where you get a variable equal to an expression like this. Sometimes you just have a variable with no coefficient. So for example here, I have an x with no coefficient. And there are two ways we could solve this. You could use the elimination method, or we can convert this to a substitution method. So to convert it to substitution, whenever I see that variable with no coefficient, I know I can use the substitution. So I'm going to subtract 7y from both sides so that I have x is equal to negative 7y. Then I have something I can substitute in. I have 2x minus 8y is equal to 22 from the other equation. X is the same thing as negative 7y. So I have negative 14y minus 8y is equal to 22. 14 and 8 is 22, so I have negative 22y is equal to 22, and that means that y is equal to negative 1. Now I know that x is equal to negative 7y, and y is negative 1, so that means that x is 7. So my solution will be 7, negative 1. Again, we could have used elimination to solve this, but if you'd like, you can set it up to be substitution. In this equation, I have a negative y, so I'm going to convert this one. I'm going to subtract 4x from both sides, and I have negative y is equal to negative 4x plus 20. But I don't want to know what negative y is. I want to know what positive y is. So I change all of the signs to get y is equal to negative, or to equal to 4x minus 20. And that is what I can plug into this equation. So I have negative 2x minus 2 times 4x minus 20 is equal to 10. Distribute that negative 2. So I have negative 8x plus 40 is equal to 10. Negative 2 and negative 8 is negative 10x plus 40 is equal to 10. Subtract 40 from both sides, and I get that negative 10x is equal to negative 30. Divide by negative 10, and I get that x is equal to 3. Now that I have x, I can go back and plug that in up here. So I get 4 times 3 minus 20, so that's 12 minus 20. So that means that y is equal to negative 8. And my solution to this system is 3, negative 8.